Good afternoon, everyone. We're going to do a video on adding mixed fractions. So this will be out of the grade 7 math curriculum. For our first example, we have 2 4/5 plus 3 1/2. And for our second one, we have much larger numbers, namely we have 50 1/3 plus 40 3/4. And so I'm going to demonstrate why, I'm going to use two different strategies, and I'm going to discuss why each strategy is better suited for the different examples that we're going to do. So for example 1, what I'm going to do in example 1 is convert both of our mixed fractions into improper fractions. Okay, I'm going to write that explicitly. We're going to convert our mixed fractions into improper fractions. And so whenever we want to do that, we multiply our whole number by our denominator. And so that's 2 times 5. And then we add our numerator. And so 2 times 5 gives us 10, plus the 4 in the numerator gives us 14. And our denominator always stays the same. So we have fifths, and so we have fifths. Likewise, for 3 1/2, we multiply our whole number by our denominator. So 3 groups of 2 makes 6, plus an additional 1 in the numerator gives us 7 halves. And now that we have our improper fractions, it's back to business as usual. We're just adding two fractions to what we've always had. And so we have our denominators of 5 and 2, so we think to ourselves, it's right, our equal signs to be proper. We think to ourselves, what would our common denominator be? I'll write that explicitly as well. Common denominator for 5 and 2, the smallest number that is a multiple of both 5 and 2 is clearly 10. And so we think to ourselves, 5 times what brings us to 10? Let's not forget to multiply the numerator by the same factor. This is such an easy mistake to make. 14 times 2 gives an equivalent fraction of 28 tenths. And then likewise, 2 times what? 2 times 5 brings us to 10. And likewise, 7 times 5 in the numerator gives 35 tenths. And now that we have our common denominator, we can go ahead and add our numerators. And so we have 28 plus 35, giving us 63 tenths. And we can also convert it into mixed fraction just if we want the practice of doing so. 63 tenths. We ask ourselves, how many times does 10 go into 63? That would be 6 times. And 6 groups of 10, 6 groups of 10 counts for 60. And so of the 63, there would be 3 of the tenths left over, okay? Again, this is not necessary to convert it back, just a little added practice for those of you that are interested. Now, for number 2, if I were to use this same strategy of converting into improper fractions, we would have massive numbers here. Now, that's not a problem if you're okay with big numbers. However, there is perhaps an easier strategy. If we were to use improper fractions, we would have 50 times 3 plus 1, so that's 151 thirds, and 40 times 4 is 160, 163 quarters. Then along with our common denominator would bring us to mightily big numbers. And so I'm going to opt for a strategy that is a little bit easier in this case. What I'm going to do is I'm going to add the 2 whole numbers by themselves, and then separately add the 2 fractional parts by themselves. And we'll put them together at the very end, which turns out to be much simpler for examples that use fairly large numbers. And so first off, 50 plus 40 gives us 90. And then for adding the 2 fractions together, we're back to simply adding 2 fractions the way we always have. And so we think to ourselves, what must our common denominator be? For thirds and quarters, that would be 12ths. Smallest number that is a multiple of 3 and of 4 happens to be 12. And so now we can get equivalent fractions. 3 times 4 gives us 12, and 1 times 4 gives an equivalent fraction of 4/12. Likewise, 4 times 3. And so 3 times 3 gives an equivalent fraction of 9/12. And now we're almost set to bring them all together in the end. We'll have 90 plus 4/12 plus 9/12 is 13/12. However, 13/12 is an improper fraction. And so if we want to combine it with our whole number, it would be wise of us to convert 13/12 back into a mixed fraction, since we're going to combine it with a nice whole number. And so 13/12 is 1 and 1/12. And now finally, we can combine these two into 91 and 1/12. Okay, if we were to convert it back to an improper fraction, just to kind of show how wild the numbers would have gotten, were we to use our improper fraction strategy, our answer would be 91 times 12. What is that? That's 182 plus 910 that's 1,000, and then plus 1, that's 1,093 twelfths, which if you're interested in practicing your cognitive abilities with large numbers, by all means, break a leg. And if not, opt for the strategy of combining the whole numbers, combining the fractions, and then putting them together at the very end, okay? I hope this was helpful. I hope you get to see the two different strategies and when it's perhaps a better idea to use each of them. If you guys have any comments, suggestions, please let me know. Any requests for future videos are always appreciated, and thanks for watching.